What is the third law of motion?
For every action, there's an equal and opposite reaction.
Third law of motion is the most misunderstood law. Okay, what does it mean? If your friend slaps you, you will slap her back. Huh? Is that the law of motion? Third law of motion, Nima? Nima agrees. Nikita, what is third law of motion?
Every action has an equal and opposite reaction.
Yes, but elaborate it. Can you give me an example? What does it mean?
For every action, there's an equal and opposite reaction as long as it doesn't harm somebody.
As long as?
It does not harm someone.
Okay. Nima, try standing up, please. And don't push the ground.
Can't do that.
Don't push the ground and try standing up.
How?
So if you push the ground downwards, how do you get up? Because of the opposite force that acts on you, right? Isn't it? Nikita, anyone who, okay, if I ask you to do some pull-ups, when you do a pull-up, you are actually trying to pull the bar down. Yes or no? And you go up. You did not create any force for you to go up. Where does that force come from? From the fact that any force does not exist in isolation. Okay, you push earth downwards and you stand up. Why? Because when you push the earth downwards, there is an equal and opposite force on you. You harder the push. Okay, the jumpers, high jumpers in Olympics, they push the earth very hard. And that's why they can jump higher. And Nima, when earth pulls you down, you also pull the earth upwards with same amount of force in opposite direction. Do you understand?
Yeah.
Okay, so that is what is third law of motion. So when earth pulls you down, your acceleration is visible, observable, isn't it? An object falling downwards is pretty easy to observe that it's falling down. We can have some sense of its speed and acceleration. But do you ever feel that the earth moves because you also are pulling the earth upwards? Why?
Because the force is not as great as...
Every action has an equal and opposite reaction. So the force with which earth is pulling you down, you are also pulling the earth upwards with same amount of force.
How is that possible if our mass is much lesser?
Force is same. And because your mass is much lesser, your acceleration is significant. Mass of the earth is huge, and that is why even if you apply same amount of force, acceleration of earth will be negligible. Understood? Okay. So let's say there is a person with 80 kg mass. What is the force on this person by earth? Tell me. If the mass of the person 80 kg into 9.81 Newton per kg, kg and kg gets cancelled, whatever this amount is, 784.8 Newton, right? Now the same force is applied on earth by you. Definitely are not 80 kg, I'm sure, right? So the person also applies same force. Now the force applied on earth is this much. What is the mass of earth? Mass of the earth into acceleration of earth, right? And what is earth's mass? Earth's mass is close to 5.97 into 10 to the power 24 kg. So what will be the acceleration? Negligible. Okay, I have a wall over here and I lean against this wall. So am I pushing the wall? Right? Is the wall pushing me in the opposite direction, right? If the wall is pushing me, why am I not falling or moving in this direction?
Because it cancels out again.
No, it cannot cancel out. That is another misconception, Arnavin. It cannot cancel out because both the forces do not act on the same object. Earth pulls you down. You pull the earth up. So one force acts on you, other acts on earth. If two forces of equal and opposite nature act on same thing, then they get cancelled. So in this case, wall is pushing me, but I'm not moving rightwards in this direction. Why?
Because your force is in the opposite direction.
If there is some net force on me, I should start moving in that direction with some acceleration, right, Nikita? So why am I not moving in that direction?
Because of friction.
Yes. If you pour a lot of oil, okay, I will not be able to stand like this. I will fall. Yes or no? I can't lean against a wall if there is no friction. Do you understand? So friction is a new force that comes into picture.